So this next example is slightly different. It says find the number of ways of forming a four-digit code in which no digit is repeated. Yes, we've already done this, and what we did before will work. That's one of the reasons why I like to pick this example to show you that this formula right here, which is the formula that we use when we have, now we have 9 things, no, 10 things. What are those 10 things? There are 10 digits. These are our digits. And then we're going to pick 4 of those. So we have 10 things, and we're going to be choosing 4 of them. Now, the method that we used is going to work out to be the exact same thing I'm going to show you. This formula is for permutation, and the reason that it's a permutation because in this problem right here, order matters. Because if we pick, if we use the digits 1, 2, 3, 4, but we rearrange those digits into 2, 1, 4, 3, it's the same 4 digits, but that's 2 different codes. So that's my explanation for what I mean when I say order matters. All right, for a code or for a license plate or for a word or for things like that, the order in which things appear, it does matter. When we get down to combinations here in a minute, we'll show you, we'll talk about what examples of combinations where an order doesn't matter. So this problem right here would be denoted if we were using the notation 10 permutate, 10 a permutation. We have 10 items, we're choosing 4. I often though say 10 choose 4 where order matters, but I know that that is a little bit confusing for people when I use the word choose because they associate the word choose with this letter C. And that's not really the case because both of these are 10 choose 4. This one could be 10 choose 4. And the only difference is that with the permutation order matters, with a combination it doesn't. So be careful with understanding my use of the word choose. The use of the word choose is in no way enough information to know if it's a permutation or a combination. So be careful with that. It took me years to realize that people were associating the word choose with the and it really shouldn't be. So this is what it would look like using the formula. Now remember, we've worked this problem. I want to remind you, we worked this problem last week, and we said that it would be 4 blanks, and those 4 blanks, no digit is repeated. So that means the first time I choose, I have 10. The second time I choose, I have 9. The third time I choose, I have 8. And then the next time I choose, I have 7. So you're going to see in just a second that with this formula, that's exactly what happens. Okay, so with this formula, first, and let me remind you again, the reason that I know it's this formula is because I have 10 things and they're not repeating, so I can only use them once. I have 10 things, I can only use them once, but I'm only picking 4 out of the 10. I'm not using all 10 of them. If I was making a 10-digit code and I could not repeat, then I would just use 10 factorial. But I'm not. I'm only using, I have 10 digits, but I'm only choosing 4 of them. And they are not being repeated. So that's how I know I'm doing a 10 choose 4 permutation. Okay, so the formula says that whatever the total number of choices that I have, which are 10 digits, that number factorial goes on top. And then on the bottom, I'm going to take my choices, which is 10, and take away the 4 that I'm choosing. So basically I'm saying what's left and put that factorial on bottom. So what that looks like is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 10 minus 4, that's 6, over 6 factorial. So 6 times 5 times 4 times 3 times 2 times 1. Okay, so anytime you have a number on top and a number on bottom, any common factors that they have can cancel out. And so remember, a factor is just a number that's being multiplied. So this factor of 6 will cancel out with that factor of 6. The 5s will reduce, the 4s will reduce, the 3s will reduce, the 2s will reduce, and then of course the 1s. So that leaves me, the answer to this problem is 10 times 9 times 8 times 7, which is exactly what we learned last week when we were using the fundamental counting method. So this formula, this is how it works if you do it by hand. Do you have to do it by hand? Absolutely not. Let's go ahead and get the answer to 10 choose 4 permutation. 10 times 9 times 8 times 7. 10 times 9 times 8 times 7. That's 5,040. Okay, so that's how many combinations are possible if digits cannot be repeated. Now, if digits could be repeated, then we wouldn't use this formula because that would not be an example of 10 choose 4. Because we wouldn't be multiplying 10 times 9 times 8 times 7. We would have to go back and use the 10 times 10 times 10 times 10. So I do want to show you using the calculator. Let's see, I had the calculator. Whoops, don't look. There it is. So you can use, if you're using this Desmos calculator, they have a fraction button. And so you could do 10 factorial. Oh, poo, what happened? 10 factorial. And then on bottom, I mean, you could type it in exactly 10 minus 4. Let's try it one more time. 10 minus 4 factorial. And it tells you that that's 5,040, just like we got. Or if you wanted to see what 10 factorial is, okay, there's that answer. And then you see what 6 factorial is. And then if you take 3, 6, 2, 8, 8, 0, 0, and divide it by 720, you get the same answer. So it doesn't matter to me how you do it. But you can type it in the calculator like that. You can calculate it by hand. I do expect you to be able to show me this. Okay, so don't rely on what I'm about to show you on StatCrunch. Actually, there might even be something else. Let me go back to the scientific calculator real quick. Yeah. So if you go over to function right here, there's this button right here. Now, I don't know exactly how that button works, so I'm going to give it a try. I'm going to type in the number 10, and then, okay, no, it's not going to work like that. So what they're going to want, you press that button, and then you probably do 10, 4. That's, I'm going to guess, yeah. So I have 10 things I'm going to choose 4 at a time. So that's definitely a super easy way to do it. Choose permutation. Notice they have combinations right there. StatCrunch will do the same thing. You go to data, you go down to compute, you go to expression, and you type in perm, P-E-R-M, and then you open parentheses, 10 things I'm choosing 4 at a time. And you do compute, and it tells you right there that it's 5,040. All right. The next problem is each year 33 race cars start the Indianapolis 500. Now, don't be careful right here. Is 500, does that have anything to do with how many cars? No, that's the name. So I have kids or students who always want to use that 500 in the problem. That's not part of the problem. That's just the name of the race. I have 33 cars entering the race. That's how many things I have. That's my N. So in this problem right here, I have N is equal to 33. And then how many ways can the cars finish first, second, and third? So I'm interested in 3 places finishing first, second, and third. Now, my question here is, does order matter? That's what you have to, does order matter? And the answer is absolutely it matters. Who wins first? If I don't know the names of any race car drivers. So Fred, Ted, and Ed. If Fred wins first and Ted wins second and Ed wins third, is that the same thing if saying Ed wins first, Ted wins second, and Fred wins third? No, it's not the same thing. So first, second, and third is an important matter. So does order matter in this case? Yes. And I'm going to tell you, watch out for first, second, and third. Watch out for president, vice president, secretary. If it's attached, if the place that we're finishing is attached to a title, then order is going to matter. So if we're going to elect a president, vice president, and a secretary, order is going to matter. You can't just say pick 3 names and it doesn't matter which one gets what. No, it does matter because first place is different than second place is different than third place. So since order matters, yes, this is a permutation. So we have 33 things. We're going to choose 3 of them. And order matters, so it's a permutation. And you can do 33 factorial over 33 minus 3, which will be 30 factorial. You can do that. Or, which is going to end up being 33 times 32 times 31, because everything else is going to cancel out after that. So you can multiply it out like that. Or you can go to this one, do compute, and do perm. I have 33 things. I'm going to choose 3 of those things and compute. There's the answer, 32,736 different first, second, and third place finishes. Or, of course, you can go to the scientific calculator and you can do NPR and do 33,3, and it gives you the same answer, 32,736. All right, I'm going to go ahead and stop this video. It's getting kind of long, and I will, the last video, I will finish up these last examples.